Hi, this is Rohan from educator.ai. Let's dive in. Your RAG pipeline retrieves some chunks and feeds them to the model. But are they the right chunks? Today we add one step that quietly fixes a lot of bad answers: reranking. A vector search returns the chunks whose embeddings sit closest to your question. But close in embedding space doesn't guarantee it truly answers the question. Often the chunk you actually need is sitting further down the list at rank 7 ignored. Think of hiring. A cheap keyword filter pulls 100 plausible resumes in a flash. Then a person actually reads the promising ones and reorders them by real fit. Retrieval is that fast filter. Reranking is the careful second read. Here's the query and 4 chunks in embedding space. The 2 nearest chunks just share the word refund. The chunk that truly answers how to get one, the actual step-by-step, sits further away. Embedding distance rewards surface similarity, not the precise answer. The fix is 2 stages with different jobs. First, retrieve wide, optimizing for recall. Cast a big net, so the right chunk is somewhere in the pile. Then rerank narrow, optimizing for precision. Reorder that pile so the best chunks rise to the top, and keep only a few. Let's build the pipeline one step at a time. Stage 1. Embed the query, run the vector search, and instead of grabbing just the top 3, grab 50. We're being generous on purpose, so the true answer is very likely inside this set. It's worth seeing how Retrieval scored things. This is a by-encoder. The query and every chunk are turned into vectors separately, ahead of time, then compared by distance. Fast and catchable, but the query and chunk never actually look at each other. That's the limitation the reranker fixes. The reranker is a cross-encoder. Instead of 2 separate vectors, it takes the query and one chunk together as a single input and reads them jointly with full attention across both. It outputs a single relevant score. Because it actually reads the pair, it's far more accurate, but you pay for it, one model call per pair. Inside the cross-encoder, attention lets every query word look directly at every chunk word. The word how latches onto steps, refund latches onto return. This joint reading is why it can tell a marketing blurb apart from the chunk with the actual instructions, something separate vectors simply can't do. Here's the whole thing. Vector search gives 50 candidates. The cross-encoder scores each one against the query. We sort by that score, and only the top 5 go to the LLM. Notice, the boxed part must happen together. You score all 50, and then sort. Because a single score is meaningless until you compare it against the others. This is the key discipline. The cross-encoder is slow because it runs the model once per pair. Reranking 50 candidates is fine. Reranking your whole index of 5,000 chunks would be slow and expensive, and would defeat the point. Retrieve cheap and wide, rerank expensive and narrow. Let's make it concrete. Same 4 candidates, 2 score arrays. Retrieval ranks the marketing blurb first, because it's lexically close. But the cross-encoder scores the steps chunk highest, because it actually reads the pair. Sort by rerank, and the chunk you send to the LLM flips to the right one. In real code it's small. Retrieve 50 hits, build query chunk pairs, and hand them to the reranker for scoring. Sort by score, slice the top 5, and only those become the model's context. The reranker is a separate, cheaper model than your main LLM, and it runs before you spend tokens. 2 mistakes to watch for. First, if retrieval only returned 5 chunks, and the answer isn't among them, reranking can't invent it. Rerank needs a wide candidate pool to reorder. Second, don't rerank the entire index, and don't forget to trim afterward. Reranking 50 then dumping all 50 into the prompt burns cost and buries the answer. So when you review a pull request that adds reranking, check both sides. Good. Retrieves a wide candidate set, uses a cross-encoder on query chunk pairs, trims to a handful, and has bounded latency. Risky. Only reranks 5, reranks the whole index, forgets to trim, or just reuses the retrieval score and calls it reranking. To recap, retrieve wide for recall, then rerank narrow for precision. The cross-encoder reads query and chunk jointly, so it fixes embedding only false positives. Only re-rank the top candidates to keep latency sane, and always trim to the top few before the model sees them.